Welcome back to Math 30-2. Today we're going to be looking at sinusoidal regressions. We're going to be using our calculator a lot today, so if you can pause the video, go grab your calculator, come right back, and we'll get started. Now, just to remind you about a regression acts as an average line for a set of data, and we've looked at a couple different kinds. You can have exponential regression, logarithmic regression. We're going to be looking at some quadratic regression and cubic regression later on. And today with the sinusoidal regression, just wanting to remind you that when we are given some data, for instance, these dots here, these coordinates on the graph, these represent the temperature throughout the year of a given city. And you can see that it kind of looks like it's going up, heading down on the other side, and it's going to be continuing, from year to year. Now, if we were to look at this closely, you're going to see that it's not a perfect sinusoidal wave. And just to make it stand out a little more, notice that over in this region right here, that this kind of is a little bit out of place. It's pretty good through here. I know these are just lines being connected, but it just shows you that it's not like a perfectly smooth sinusoidal graph. However, when we do a regression, what it does, it takes the average of all the points and fits it into the best model possible. In this case, a sinusoidal graph. And we can see that some of the points are above the line, some are below the line, some are right on the line, but this line here represents the best average sinusoidal function for this data set. So that's what we're going to be doing today. We're going to be looking at data sets and finding these regressions of the sinusoidal function. So for sinusoidal regressions in a TI calculator, we're going to be using the features stat, calc, and c. And it's going to give us a sinusoidal regression, and it's always going to be written in this form of y equals a sine bx plus c plus d. And you're going to be wanting to make sure that you can put that in the Y1 or Y equals button so that we can graph it. And we are going to be using VAR's number 5 equation on that. There's other ways to use the VAR's button to get the variable there, and we'll look at that option as well. So let's look at an example. The table below gives the time in minutes versus the height in meters of a Ferris wheel. We love a Ferris wheel in sinusoidal functions. And the diameter of the Ferris wheel is 76 meters. So the first part, it says, perform a sinusoidal regression and round the parameters to the nearest hundredth if necessary, meaning if it comes out as a whole number, you're okay to leave it like that. Otherwise, make it rounded to 2 decimal places. Well, the first thing I've done here is in our calculator, we're going to hit stat and 1 for edit. And we're going to put in the list 1, we're going to put our times. And in the list 2, we're going to put our heights. So we're going to make sure that we have all those numbers in correctly. One of the biggest problems with having a sinusoidal or any kind of regression function is putting in the data incorrectly. So you always want to make sure you do a double check on that. Once you have your data in, we're going to do that sinusoidal regression by pressing stat. This time we're going to head over to calculate, so tab over with your arrow. Now you can head on down by doing this to find it. Or in this case, you can just hit up once and it brings you to the bottom of the list and hit enter, or you can put in C. Now that we have that here, we can hit enter to find the sinusoidal regression, or we can do everything in one step and hit VARS, YVARS, 1 for function, and put that there. If we do it this way, it will automatically put this into our y equals button for us in one step. We can do it that way, or we can do it the other way, and I'll show you that the next round. Now we hit enter, and now we have our variables A, B, C, and D. Notice A and D are whole numbers, so we're not going to round those. We're just going to round B and C. So when we write that out, let's get some pencils going on here. We get y equals 38 sine of, now here's where our rounding takes place, 0.70. Let's go with the variables they gave us. It was actually an h right there for height. And this is t for minutes. Minus 1.57 is what the c value is rounded. Notice it's a negative 1.57, so this is going to become subtraction. And then we get a plus 46 right here. So let's answer some questions based on this regression equation. It says determine the period of the graph. Well, we know what to do here. We know that the period equals 2 pi over the b value. And the b value in this case, we're going to use the unrounded version. So we're going to say 2 over pi, and we're going to put in 0.698131, something like that. We could double check with our calculator just to be sure. 0.698131. Perfect. That's enough decimal places to avoid rounding errors. So coming back, when we put this in our calculator, if we round this to the nearest, let's stick with 2 decimal places, we get 9.00 minutes. And it's asking us to describe what this represents. Well, we know, we've done a lot of Ferris wheel questions already, that this represents the time it takes for the Ferris wheel to go around once. So let's write that down. The period represents the time for one revolution. Let's do C. What is the relationship between the amplitude and the diameter of the wheel? Well, we know that the diameter of a circle, that equals 2 times the radius. But because we've done a lot of these already, we know that the radius of the Ferris wheel, when we're looking at a sinusoidal equation, can be the same as the amplitude, which is the absolute value of the A. So in this case, we notice that the diameter was 76 meters, and sure enough, 2 times the absolute value of the A, which is 38, also equals 76 meters. So the relationship is the diameter equals twice the amplitude. Part D. How high above the ground did people board the Ferris wheel in this scenario? Well, we know when we look at a Ferris wheel that they get on at the lowest point. In other words, they get on at the minimum point, the minimum Y value. And we've seen this a few times now, that the minimum value equals our median value, which is represented by D in the formula, minus our amplitude value, or our A. So when we put this in, we get 46, which was the median value. Yeah, right there, that's that median value. Subtract 38, which is our A value. And when we put that, we won't put that in our calculator. We know this. We got this. We can do some of these things in our head. We get 8 meters. In other words, the height, people board, the Ferris wheel is 8 meters. Here we go. Next question. How far above the ground would a person be after 3 minutes? Okay, so we're looking at what is the height. The real question is, what is h? That is the height when t equals 3. So that's how we can frame it in terms of h and t. So we could take this, we could put t equals 3 into the formula. The thing with the formula as it is, that's not going to give us the best value because we used rounded values here. So if we put this into our calculator, it may be a little off. So while we could do this, we would want to hold on to more of these decimal places. The other way to do it is we can graph the regression equation, and we're going to do that in a second. And instead, we can go second trace 0 for value, and we can make x equal to 3. So let's go ahead and do that in the calculator. So already when we did that, remember I put the y1 after the regression and it automatically put it here. So now we have that. We need to check our window settings. Now this thing has a minimum. We already determined the minimum was at 8 meters. So we're going to have a y min of 0. The diameter was 76, so that means the height is definitely, we want to get it up to 90 to make sure the whole thing fits in. And the period of this thing was 9 minutes. So if we go from x0 to 10, we are going to get 1 full revolution in there. So let's go ahead, keep that there. We're going to change our y min from 0 to the max of, let's say, 90, just to see it show up, and we can have this go up by tens. So we adjusted our window setting. Remember, we want to make sure that we have this at radians. We might have been doing some degree work somewhere else and maybe have not reset our calculator. So we want to make sure we're in radians, and then we're going to hit graph, and there we go. So there we have it. We have 1 full revolution from min to a min. So it's all in between 0 and 10. So let's go ahead and go second function trace and go 1 for value. And now we're going to put when x equals 3 right here. And when x equals 3, y equals 65. So in other words, the person will be 65 meters off the ground after 3 minutes. Okay, let's do the next question. It says, at what point or points, okay, that's a good clue, is a person 15 meters above the ground in one full revolution? So now what we're doing, we are going to be finding when our y1, say, equals 38 sine of 0.70t minus 1.57 plus 46. Our y2, we're going to make 15. I want to point out, in any time you are being asked to do this kind of question, when you're showing the person who's assessing you, you want to make sure you include this. So you have to include what you're putting in for Y1 and Y2 when you're doing any type of calculator work like this. So now that we have that, we need to find the intersection of Y1 and Y2. So second trace and 5 for intersect. So let's go ahead and pull out the calculator again. This time, we go back into our Y1, Y2. We're going to bring down to 15. Hit graph again. There we go. So now we have 2 points of intersection in one revolution. We have the first one here, and if we look at it, it looks like it's a roughly around 10, a little bit around there. And then this one here is a roughly between 8 and 9. So going second trace, hit 5 for intersect. We're going to move this all the way over to the first one. And then we're going to do our enter, enter, enter. And it says when x is, or when y is 15, when the height is 15, that will occur at time 0.8833 minutes. So that's our first one. Let's go ahead and find the second one before we write these down. Second trace and go 5 again. And this time we have to go all the way over. Let's do it this way. There we go. The closest point, the shortest distance between 2 points is a straight line. So let's do it that way instead of going over the hill. So we hit enter, enter, enter. So when y equals 15, the time equals 8.11. Okay, we got that. So let's write these down. So the points are going to be 0.883 and 15. And the other point was 8.116 and 15. 2 sixes. We can round to the nearest thousandth and make that a 7. If you like, let's do that just for consistency. There we go. So those are the points that are above the ground. But the next question says, how long to the nearest tenth of a minute is a person in one revolution when he is at least 15 meters above the ground? So going back to the graph, I'm just going to hit graph to get rid of that. So when he's at least 15, all through this portion of the motion, right here to here, he is 15 or above. Immediately below the line, these portions don't count. So to determine the amount of time, we need to find the difference between this time, we'll call it T2, and the first time it was 15, and we'll call that T1. So we want to say T2 minus T1 is going to equal the length of time that the person is 15 meters or above. And that means we're going to have that 8.117 minus that 0.883. And when we put that in the calculator and round it to the nearest tenth, we get 7.2 minutes. So the person is at least 15 meters for 7.2 minutes. Let's keep going. So let's look at example 2, where they give us some more data. This time it is temperature in degrees Celsius for Cape Town from January through December. And it's asking us, first of all, to write the sinusoidal regression to the nearest hundredth. So let's break out the calculator again. We're going to clear the data from our previous time. Just hit up, and when it's there, we can just hit clear and hit enter, and it gets rid of everything in that column. So let's do the same thing again. Hit up, clear, enter, and it cleared it out for us. Now notice here, the months are given January to December, so we are going to number them 1 through top 12. So in our first column, we're just going to hit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The next thing, we're going to put in the temperature data. So making sure that everything is lined up very nicely here, that we are making sure that we're lined up with 4 goes with April, which goes with 22. Good. And then just keep entering them in. And we're at October, which is the 10th month. That's good. Like I mentioned, this is kind of where a lot of mistakes happen. So now that we have that in, we're going to do our sinusoidal regression. So stat, over to calc, up for C, enter. Now this time we're going to do it a little different. To find our regression, we're not going to hit that, we're not going to put the vars, the Y one in here. I'll show you the other way this time. So we're going to hit enter. Wait. There you go. Now, if I needed this in my Y equals button, I can just head on over to Y equals. I'm going to clear that one. That was the time before, the last example. This time, I'm going to hit enter, or sorry, I'm going to hit vars, and then I'm going to go number 5 for statistic. Then I'm going over to equation and picking 1 for there, and now that's put it in there for us. So which way you want to do it, that's up to you. So quitting out of this, here we go. This is our sinusoidal regression on this, and we're going to round things to the nearest hundredth. None of these are whole numbers, so we're going to say 6.29, 0.52. This one's a positive 0.96, and this has to be rounded to 0.97 and 21.45. So let's write that down. So in this case, we're going to say temperature T equals 6.29 sine of 0.52 meters plus 0.97. Notice our C was positive, so it's a plus 21.45. So let's answer a few questions on this regression. What is the highest temperature? Well, the highest temperature is the Y max, and we know that happens when we take our median value and add the amplitude. In other words, when we take the 21.45562. So we're going to be using unrounded values for these calculation type questions. Okay, so the highest temperature, we can just go ahead and put 21.44562 plus 6.29215, and that should equal 26.74 to the let's stick with to the nearest hundredth degrees Celsius. Now we can do that using this way. If you like, you can go ahead and graph this guy. Okay, and to graph it, we would have to adjust the window settings. We don't need to go up to 90 on this one because the amplitude is only 6 and the median is 21.45. So if we say go to about 30, we should be solid there. And that means we're just going to adjust that to 2. And because this is a 12-month cycle, we're going to change that to 12 and hit graph. There we go. So we could also use the max feature on our calculator. So we're going to go second function trace, and this time 4 for max. So we head on up. We have to go to the left side of the maximum first. Now it's a little hard to see because we didn't put our Y up as much as probably we should have. We can go back and fix that. Oops, mode, second quit, window setting, there we go. Let's make this a little bit higher just so things aren't in the way. Do that one more time with feeling. There we go. Wait for it again. Second trace, and this time 4 max. So we're going to head over to the left side of that maximum. There we go. Hit enter. Now we have to go to the right side of the maximum. Hit enter. Now notice the 2 arrows, that's where it's going to look for that maximum. So we wait. Oh, it looks like I put this in my calculator wrong. Yeah, look at that. I added it up wrong in my calculator. So it's 27.73. I wrote that down wrong. You're probably all yelling at me saying, hey, you added that wrong. So 17.74. Perfect. Now it's perfect. Now we could do the other thing. We can do the lowest temperature. Now, again, if you like to do it on your calculator, I just showed you how to do the max. The min is similar, but let's just go with the minimum temperature equals D minus A. And in this case, that's going to be 21.44562 minus 6.29215. And putting that in the calculator, we get 15.153. So we're going to just round that to 15.15 degrees Celsius. And what is the average temperature? Well, the average temperature is the median value. So the average temperature is just D, which rounded to 2 decimal places is 21.45 degrees Celsius. Now, what about the period of this? Well, we know that the period is 12 months. But remember, we've done a regression. So the regression might tell us something a little different. And we'll just do a quick calculation. And that means we're finding the period. The period equals 2 pi over the b value. And we're going to use the unrounded value, 0.5247. Okay. And when we put that in the calculator, I get, and always check my work and let me know if I'm wrong, but I get 11.97, which is very close to the 12 months that we kind of assumed it to be. Okay, so if we were to round this to the nearest whole number, it would be bang on. So how many months is the temperature below 20 degrees? Well, we're going to do the same thing like we did in the previous example. We're going to make our y1 equal to that 6.29 sine of 0.52 months plus 0.97. Remember, we have to write this down to let the person who's assessing us know that we know what we're doing. We are going to find the intersection between 2 points or 2 lines, y1 and y2, and we want to find what month is it going to be at 20 degrees. So let's go ahead and go back to our calculator. Now remember, we have already put that in there. So we just need to add the 20 into our y2. Graphing again, there we go. So now this time it says, for how many months is the temperature below 20 degrees? So that's going to be from the first intersection right here over to the second intersection right here. Because remember, the x coordinate of that represents the time that 20 degrees occurred. So we're really dropping a line down to find the x value here and over here, and we're going to find the difference between those two values. So we go ahead and we're going to find second trace and 5 for intersect. We're going to head on over and go enter, enter, enter. The first one occurs y equals 20 when x equals 4.585966. We'll hold that, write that one down. We'll come back to it in a minute after we do the second intersection. Second trace, 5 for intersect. And heading on over, let's just go the quickest way over is on the straight line. And go enter, enter, enter. When we do that, when y equals 20, or when the temperature is 20, it's about 9.689663 months. So now we have those two values. So let's go ahead, write those down. Our T2 minus T1 is going to tell us how many months. And our T2 we determined to be 9.68966 and change. Holding on to a bunch of decimal places so we don't get rounding errors. 0.4896 equals. We're going to round this to 2 decimal places, and we're going to say about 0.10 months. So in other words, the temperature is below 20 degrees for about 5.10 months. So just a little bit above 5 months. There you go. And just a reminder with any of these videos, if you have questions, remember to get in touch. I'd be happy to help. So for number 3, they have given us a group of ordered pairs. And we can see that we can see that this would potentially be a sinusoidal function. So we could do a regression on this. So we're going to find the regression equation. Then from that, determine the amplitude, the period, and the range. Now, it might be nice in cases where they just give you these ordered pairs, is that we just make a little table of values for ourselves so that we're not kind of going back and forth between the x values and the y values when we put them into our list in the calculator. So if we label x and y, we get 0, 2, 4, 10, 6 and 15.66, 8 and 18, 12 and 10, and 16 and 2. So what I'd like you to do right now is put these into your list 1, list 2, and determine the equation. So pause the video, and when you come back, I will have the equation done for you. Okay, how did you do? So I went ahead and I put those ordered pairs in my calculator, list 1 and list 2. I did my statistical regression on that, and I got 8.02 as my A value, 0.39, negative 1.5. I had to round this to an 8, and 10.03. I had to round the 2 up to a 3. So the first thing the question is asking, what is the amplitude? Well, the amplitude is the absolute value of our A, and we know that it is 8.02. This is unitless, so we don't have to worry about units here. For the period, we're going to say the period equals 2 pi over our B value. Now, in the B value, we're going to use the unrounded value of 0.39497. And when we put that in the calculator, it's going to give us 15.91 rounded to 2 decimal places. Now for the range. We could go ahead and find the max and the min using a calculator if you want. You're more than welcome to do that, making sure if you do that, you would say second trace. And then for finding the max, it is, I think it's 4, I think for max, and then 3 for min. So make sure that you are including that if you're going to do that way, to let the person know how you came up with that value. Otherwise, we're just going to go with our regular min equals D minus A. And in that case, we get this 10.0297. So that's the unrounded value from here, subtracting 8.0217. And it gets 2.01. The max, same thing, except we're going up instead of down. So D plus the A, and we get 0.297 plus 8.0217, and rounded to 2 decimal places, we get 18.05. So now that we have our minimum, our maximum, we can figure out the range, and the range is y, such that starting with the minimum, always start with the minimum, less than or equal to y less than or equal to max, where y is an element of the real numbers, and get our little curly brackets in there. There we go. How'd you do? Did you get it? I hope so. Let's move on to the last one here. So you may notice there's a theme with these sinusoidal equations when we're talking about contacts. Spinning wheels, first one. Tides is another one, and temperatures again. Here we go again with temperatures. So these are the main contexts that we're going to be seeing these in. There are others, so don't be surprised if you do see one, but again, These are the main ones. So in this one here, the average daily high temperature of Montreal in degrees Fahrenheit for each month of the year is shown in the table below, where January equals 1, February equals 2, so forth and so on. So again, I want you to put this into your calculator, okay, and come back and see how you did. Okay, so let's go ahead and do that one. So going back into the stat, hit 1 for edit. You're going to clear that one up and go over and clear that one up. So we're going to put in 1, enter 4, 6, 8, 10, and 12. Arrow over brings you back to the top. 22, 52, 75, 77, 51, and 28. Now that we have those in there, we're going to hit Stat, arrow over for Calc, up, and Enter. Now that we have that one there, I'm going to go ahead and just go through the motions here. I'm going to go vars, y vars, and 1, 1. So that is going to tell the calculator when we hit enter to put it in y1 in the y equals button. And we just wait. And did you get that one? We get y equals, let's round everything again to 2 decimal places because it says the nearest hundredth. So that's y equals 28.58 sine 0.51. We're going to stick with M for months. I guess we can really make this equal to temperature as well. So let's say T for temperature. And then we're going to subtract this time. Our C value is negative. And then adding our D value of 50.93. Now you may have noticed our D values have always been positive in these examples. Please note that they can be negative as well. If a scientist predict that the average daily height in degrees Fahrenheit will increase by 1.2 degrees Fahrenheit each month, what characteristics of the graph of the sinusoidal regression function would change? So let's think about what that's saying. That means everything in the second column right here, the average daily temperature, we're going to add 1.2 to every single one of those things. 1.2 is the way, 22.1.2, all of these all the way down. So let's think what that's going to do to our graph. So here's a sinusoidal function. It's not the one that we just graphed, but I just wanted to show you this as an example. So I have this graph here, and notice that it goes through 0. So that means the median value is here. If I took this graph and added 1.2 to every point, so this 0 would go up to 1.2, this 1 would go up to 2.2, so forth and so on, we're going to get something like this. Okay, let's shift it down a little. So really, the whole graph has moved up 1.2. Well, what did that do to our maximum value? Well, clearly our maximum value has increased by 1.2. But it just didn't increase the max. It also affected the min because the min, which was down here, that went up to 1.2. And what about the D value? Well, the D value there was this line right here. Okay, that was the D value. But now the new D value, look, it's at 1.2. So our median line also changed. And let's just put them in to make it super clear. Okay, so I put in those D values. So you notice it goes from here all the way down. There we go. Let me get my highlighter. And then here's the new D value. So far we see the max has changed, the min has changed, the D value has changed. But what about the period? Well, if I look at one full revolution of this, let me just move this over so we can see one full revolution. Notice it started here and finished here. Well, this one also started here and finished here. So by moving it up, it didn't really affect the period. But what about the amplitude? Well, the amplitude is the distance from here to the max. Well, here it was 1 unit. If we looked at this one, though, it goes from 1.2 to 2.2, so it's still 1 unit. So the things that get changed when everything gets shifted up, or could be shifted down, is that the max, the min, and the average, or the D, they all get changed. But the period and the amplitude remain the same. So we can write down here that our amplitude, there is no change, because as I showed with our example, that the amplitude is the same height. The period didn't change. However, the median, the maximum, and the minimum, they changed. And in particular, they were all increased by 1.2 degrees Fahrenheit. So if the same amount is applied or increased or decreased, the maximum, minimum, and median will also increase or decrease by that amount. And here we add 1.2 degrees Fahrenheit. Well, that's the end of this video. If you have any questions about sinusoidal regression, please don't hesitate to get in touch. I hope you have a great rest of your day. Take care.